Hey there, this is Horner, and we're looking at the waves and sound free response question number 1. This is a 7-point problem. You have a student connects a string to an oscillator, and the other end of the string is connected to a wall. The student sees a crest of 1 centimeter and a trough of 1 centimeter as it travels across. So the crest goes first, followed by a trough, followed by a crest and a trough, and it keeps going. This happens, this 1 centimeter crest or trough was moving to the right with a speed of, it says here, 1 millisecond. Okay, so every millisecond it moves 1 centimeter to the right. On the diagram below, on this diagram, they want us to sketch the shape of a waveform at the instant that t is equal to 5 milliseconds. So what we'll do is we're going to say that this whole thing shifts to the right 5 blocks, and it's because I'm going 1 centimeter per millisecond, so I'm going to go 5 centimeters in 5 milliseconds. You'll notice though that when I do that, this one goes over 1, 2, 3, 4, hits, and then it has to come back. And remember, when you hit a fixed end, you come back upside down. So you'll see here, I tried to do these in a couple different colors. And then the colors bled out when I put this, this blue line on top. So what I'm going to do is I'm going to erase what's here so that you can see a little bit better kind of what's going on. The back end of this waveform is also going to travel 5. So we're going to say this is starting here, it goes 1, 2, 3, 4, and then this is 5. So this is where the back end is. So let's start with that back end. We're going to make this one red. So this comes down, comes back up, just like the original. It goes up, comes back down, goes down, and then comes back up. Now, our problem is this is what's left of the wave, but we still had that front part, which is green. So I'm going to change my color to green, and I'm going to show you what the green should look like. This green, when it hits the wall, remember, comes back upside down. So now I have both a green and a red trough. Because of that, this is constructive. So remember, constructive means you're going to put them together, interference. And because there's constructive interference, let's draw the overall line using a highlighter, and I'll make it so that it's not so thick. But the highlighter is going to show you the overall wave. So we're going to follow the red line, and then when we get down to the bottom here, because these two are combined, we're going to go ahead and put what they look like combined. Oops. So I'm going to start, I'm going to try to, I probably need to just start over here. Ooh, it's going to give me fits. So, oh my, it's going to give me constructive. So let's go back and undo that. Sorry about this. Alrighty, so let's just grab this pen again and see if we can get it to work. So it should be all the way down here. So it's going to come all the way down to the bottom and all the way back up. So what you'll see is the total line all the way through. What I'll do is I'm going to erase what's there so you can see what the complete answer is. But essentially what's happening is you have constructive interference here at the very end of this wave. So I'll go back and just do the whole thing in red or in green, whichever one comes up. So this goes down, it comes back up, it goes down, and then it continues all the way down and then comes back up. Okay. If you look at the answer key that I've provided too, you'll see it there also. But because the initial wave is flipped upside down and this one is running right here now, you've got to add those two together. So a lot there. Let's go on to letter B. Another student is observing the situation and attempts to draw the graph of the height of the string at point P as a function of time, and this is what they end up drawing. Okay. I've also drawn some other things on here. The student correctly draws this flat segment right here, and they want to know why this section of the graph is complete. Well, you don't have colors to do this with, so you'll have to explain it. So you just say that the original wave reflected and is inverted, and then the next wave coming in is still upright. So the red here shows the upright, the green shows the reflected wave that came off the wall. How could you do this on the AP test since you only have one color to work with? Probably the easiest and the best thing to do would be use dotted and dashed dotted line and a line that is not dotted. So what I would do for this one is you could draw the wave, so this is that green one that you see, we'll draw it solid, and then the red one you could do as a dotted line. And you could say that the dotted and the solid lines cancel each other out and they make that flat line. So that's essentially what it is. There's an incorrect feature of the graph outside of the interval of 5 meters per second less than t less than 7 meters per second. So that's this area outside of this area. So that's over here. And from 7 to 9, instead of having this waveform, since it's reflected, it should be upside down. And so you want to draw it upside down, and you could show it and identify the feature and explain how to correct it. It should be inverted, and I would actually show it because I think that's an important thing to do. For letter C, the student wishes to reprogram the oscillator so that the fundamental standing wave will be created on the string. Explain how the student can do this, including a specific value frequency or period in your response. So your distance from your oscillator to your wall here, you'll notice they've done 2 centimeters, okay, or 0.2 meters. You could move the distance of the oscillator to 0.1 meters. If you do that, then your wavelength is 0.2 meters. Your velocity is 10 meters per second, since 1 centimeter over 1 millisecond is 0.01 meters over 0.001 seconds, and that gives you a speed of 10 meters per second. Your frequency then would be that 10 divided by that wavelength, which is 0.2 meters, and that would end up giving you 50 hertz. And that's how you would reprogram it so that that fundamental standing wave would be created on the string. And I think that is it. One thing you might want to see here is this is that original that you see where you get that 1 centimeter, so you've got 0.2 meters, so that you end up with that wavelength. And that is the end of the first one.